Let's take a look at question number 2 from the week 6 linear systems worksheet. This is a mixtures application, and in this application we are creating sterling silver, which is an alloy of silver and copper. And we're doing that by using two different silver-copper alloys, one which has too much silver, so one that's 94% silver, and another that has too little silver, which has 85% silver. The question is, how much of each of those alloys do we want to combine in order to make sterling silver? With any mixture problems, I find it quite helpful to set up a chart. You don't have to use this method, but I find it to be a good process to organize all the information that we're given in the question. So to build our chart, we're going to want to list all of the materials that are involved. So that's going to be the first column in our chart. And we're combining two different alloys. I'm just going to call them alloy A and alloy B. You can call them whatever you want, but I'll put alloy A as my first material, alloy B as my second, and then we're combining them to make sterling silver. So I'll just call the final mixture sterling silver. You could call it final, you could call it alloy C. It doesn't really matter as long as you know what your names are referring to. So we have our materials. We want to know a lot of different information about these materials. The first thing that we want to know is the total amount of the material. And then we're going to want to know the amount of copper and the amount of silver in each of those alloys. To know the amount of copper and the amount of silver, we're going to need to know the percentage of copper and silver in each of those materials. So I'm going to put percentage silver as one column. And then I'm going to put amount silver as my next column. Then I'm going to put percentage copper as another column, and then amount copper as my final column. And I'm going to use the information from the question in order to fill out this chart. So let's just read through the question and see what information we've been given. We're told that sterling silver is 92.5% silver, so that's going to be the percent of sterling silver in my final mixture. I'm going to write it as a decimal number by dividing my percentage by 100, so it'll be 0.925. And we're also told that it's 0.75% copper, so we're going to make that as a decimal number by dividing by 100 as well. The percentage of copper will be 0.075. Next, we're told that one silver-copper alloy is 94% silver, so that's our alloy A. We can write the percentage of silver as 0.94. And it doesn't tell us how much copper is in this first alloy, but we're told it's a silver-copper alloy, so we can assume that any material that isn't silver is copper. It would have to give us extra information if there was a third metal in this alloy. So our percent copper then is just going to be 1 minus 0.94, which is 0.06. And then we're told that the second silver-copper alloy is 85% silver. As a decimal number, that's 0.85. And again, since we're told that it's a silver-copper alloy, we can assume that any material that's within it that isn't silver is copper, so the percentage of copper will be 0.15. And you'll note that these percentages don't add up, and they shouldn't. What is going to add up are the values that we put in our amount columns. So when we read the last sentence of the problem, it says how much of each should be used in order to make 100 grams of sterling silver. So that tells us the amount that we want of our final mixture, which is 100 grams. And it also tells us how we should define our unknowns, because it's asking us how much of each alloy should we be using. So that's what we want to be solving for, so that's where we're going to assign our variables. We'll let the amount of alloy A be represented by A, and the amount of alloy B be represented by B. And now we can go ahead and fill out our other two amount columns. And we do that by using an equation that tells us to figure out the amount of silver, for example, in this alloy. We're going to take the total amount of the alloy and multiply by the percentage of silver. And that should make some sort of intuitive sense to you. If you have 100 grams of alloy A and you know that it's 94% silver, you're just going to multiply 100 times 94 to get that there are 94 grams of silver in that amount. The difference here is that we don't know how much of alloy A we're using yet. So instead of having a number in this column, we're just going to write 0.94A. And this is the expression that will give us the amount of silver in our alloy depending on how much of the alloy we have. And we can just multiply across for each of the values in this column. So the amount of silver in alloy B will be 0.85B. And the amount of silver in sterling silver, because we know we're going to have 100 grams, is just going to be 100 times 0.925, or 92.5 grams. We're going to do the same thing to fill out the column for the amount of copper, but now we're multiplying the percentage of copper by the total amount. So the amount of copper in alloy A will be 0.06A. The amount of copper in alloy B will be 0.15B. And the amount of copper in sterling silver is going to be 0.075 times 100, which is just going to be 7.5 grams. We should now be able to develop a number of equations that are going to help us to solve this problem. What we know is that the total amount of material A plus the total amount of material B must be equal to the total amount in our final mixture. So that's going to be our first equation. A plus B is equal to 100 grams. We also know that the amount of silver in alloy A plus the amount of silver in alloy B has to be equal to the total amount of silver in our final mixture. So that means that 0.94A plus 0.85B has to be equal to 92.5. And the amount of copper in alloy A plus the amount of copper in alloy B has to be equal to the total amount of copper. So 0.06A plus 0.15B is equal to 7.5. So here we have a system of 3 equations and 2 unknowns. We can number these equations 1, 2, and 3. And we actually only need 2 of them to solve the problem. We saw another example like this in class, and we had some people solve a system like this by just using equations 1 and 2. Some people solve by just using equations 1 and 3, and some people solve by using just equations 2 and 3, and each time we got the same answer. So I'll show you one solution. We'll use equations 1 and 2 to solve, but you can go ahead and try to solve using equations 2 and 3 or 1 and 3. You can use your calculator or you can do it algebraically. You should end up with the same answer each time. So this question has actually given us more information than we need to solve the problem. I'm going to solve algebraically because I think we all need a little bit more practice with algebraic solving. And equation 1 here is really nice. The coefficients on A and B are both 1, and that means that we can easily manipulate it by multiplying it by some constant and doing elimination. Or we can isolate one of our variables and do substitution. I'm going to choose to use substitution, but you could try it by elimination as well if you'd like. And I'm going to start by rearranging equation 1. I'm going to isolate A, but you can easily isolate B as well. To isolate A, I'll get that A is equal to 100 minus B. We'll call this equation 4. So once we have equation 1 rearranged and A isolated, we can substitute it into either equation 2 or 3. I'm going to choose to solve using equation 2, but you should get the same solution using equation 3 as well. So I'm going to write substitute 4 in 2. And then I'm going to go ahead and replace A with 100 minus B. When I do that, I should have 0.94 times 100 minus B plus 0.85B is equal to 92.5. And now I can solve this equation for B. 0.94 times 100 is 94 minus 0.94b plus 0.85b is equal to 92.5. And now I can collect like terms to simplify this equation. If I keep my constants on the left, I'll have 1.5 on the left, and on the right I'll end up with 0.09b. And then if I divide both sides of the equation by 0.09b, I should get that b is equal to 16.667, or we can just round to 16.7 grams. So we've solved for b. We have to figure out what a is. Probably the easiest way to do that will be to substitute b is equal to 16.7 grams into equation 4, where we already have a isolated. So we're going to substitute b is equal to 16.7 into 4. And when we do that, we'll get that a is equal to 100 minus 16.7, which is equal to 83.3 grams. Again, you're going to want to check this answer. You can check it by substituting these points back into your 3 original equations, making sure they all check out. Or you can also check it by using the solver function on your calculator.